So we're going to have a slightly shorter session. We're not going to be able to have as much time for the plenary discussion. I'll do my best to make sure we do have time for that. But we've got Alex Millward from Desmos joining us online at 12:30, and we can't be late for Alex's diary, so that will start at 12:30. So for now, the first speaker we're going to have for the What's Next session is Hannah Galbraith-Olive from GCCSI. So Hannah, thank you very much. If you want to introduce yourself.
Thanks, Jen. I'm just going to make the microphone get lower down. That's much shorter than most of the previous speakers. Anyway, thank you. Yeah, I'm Hannah Galbraith-Olive, and I'm from the Global CCS Institute, and my role is the Senior Technical Policy Manager for Europe. But my background is as a geologist, so I'm always very interested in the subsurface, and I spent a few years in consultancy working for a company called ERN on CCS, lots of CCS projects all over the world, and now I've moved fairly recently. I started in January for the Global CCS Institute. And I think today I'm giving a very high level what's next for CCS from a global perspective. I think we've heard a lot of very interesting talks throughout the conference, and like Jen alluded to, we've heard a lot about what's next for individual projects, for individual clusters, and this is very much a global overview. But first, what is the Global CCS Institute? Most of you are hopefully aware of what we are, but just to reintroduce ourselves. So we're an international CCS think tank, and we were set up in the mid-2000s by the Australian government. So our headquarters are in Melbourne, Australia, but we have offices all over the world, or virtual offices all over the world. Our CEO's based in Washington, and offices in Beijing, Japan, Abu Dhabi, and I'm based out of our London office. And we're supported by over 200 members from across the world. These include not only industry, but also government. So, for example, the UK government as one of our members. We have the US government as one of our members, the Chinese government, etc. So we operate in that space between government, between industry, and a bit between academia as well, developing fact-based inferential advocacy, thought leadership pieces, and knowledge sharing. So probably what some of you are most familiar with is our Global Status of CCS report that we publish every year in October. So every year, or I'm supposed to be writing our Europe section right now, and every year in October we'll publish the Global Status of CCS. We track what projects are coming online, how that's changed from the year before, and so what's moving and how it's moving in different regions. So a lot of what I'm going to present today is from the 2025 Global Status Report. Obviously we're working, and this has been constantly updated, and the 2026 report will be released in October. So this, I think, has been highlighted already by some people, that inflection point, that 9% increase in storage capacity, or stored CO2 that Sam showed, and this is in terms of capture capacity. So, and number of facilities in operation. So the graph is in terms of the number of facilities in operation, and we can see between 2024 and 2025, there's a 54% increase in the number of facilities in operation. So 77 new facilities came online in that period. And currently there's 64, as of October 25, there's 64 megatons of capture capacity online, which is coming online in that year, which brings us up to a total of 513 megatons of total capture capacity. So you can see we're really at this place where if we were to fit a trend line through it, there's a few bumps in the road, obviously in the mid 2010s, and then that exponential increase that we're hoping is coming, is starting. And CCS is moving beyond the kind of more early demonstration, first-of-a-kind projects into that commercial deployment space. Just looking forward, the title of the talk I was told was What's Next? So looking forward to 2030, these graphs are purely, they're not any kind of speculation, they're purely based on announced projects. So if we just look at announced projects, CCS projects, which as the Global CCS Institute we track in our core database, we can see that there's a huge growth in CCS capacity. So from these planned projects is low carbon hydrogen and ammonia projected to be the largest deployment sector, with more than 100 million tonnes of new capture capacity. but also strong growth in power generation and heat and natural gas processing as well. And if you look on the right-hand side, which is the regions, we can see that North America is likely to remain the global leader, and obviously there's some politics behind that, but given their already deep knowledge base in North America, that is likely to expand, and Europe too is set for a major surge. So we're currently at 3 megatons as of 2025, and set to grow to over 90 megatons per year by 2030, so growing to be the second largest region in terms of CCS. And so I think that this slide is the aim is to underscore how robust the CCS pipeline is, and how robust or how many projects are due to come online by 2030, and how that exponential growth curve will continue. Just to kind of bring it back to what I focus on a lot of the time, which is more on the policy side of things. One of our favourite sayings in the Institute is where there's policy, there's projects. And that's one of the clearest patterns that we see globally. Countries with well-developed CCS policy and regulatory frameworks tend to have that stronger project pipeline. And I think we had a bit of that discussion in the panel earlier, but however you break it down, you need some kind of subsidy for CCS. CCS is likely to be more on the waste management side, and it needs some carbon price to incentivize, or carbon tax credits, or something to incentivize the deployment of it. And more and more importantly, we're seeing that it's the policy and regulatory clarity and long-term certainty which is really driving projects. So it's not just that you've got your regulations in place, but you know those regulations and policy is going to stay for the next 25 plus years when you're looking to invest in a 25-year long project. Just wanted to touch on how different regions of the world are deploying this, and this is a super high-level slide. More than happy to get into the details of these with you in discussions later. But the way that CCS is supported is different across different regions, and a lot of this is based on the kind of political context, but also the industrial context, where the industry is, how they connect, and where the storage is, and how that connects together. So North America is very much driven by market-based incentives. We've got the 45Q tax credit in the US as an example, whereas in Europe we see much more of the project selection through contracts for difference schemes. So project selection to receive contracts for difference, to pay the difference in price between the EU ETS price or the UK ETS price and the cost of deploying CCS. In the Middle East, we see projects more often than not led by the national oil companies, and very much in support of integration and production of low carbon hydrocarbons, if that makes sense. So low carbon ammonia, low carbon hydrogen, and things like that. In Asia Pacific, it's a bit more uneven policy and regulatory development, but crucially, governments are playing that central role in early project development and coordination between different players. And I think just to highlight here is that while these different approaches differ, the aim of all of them is to get to that gigaton scale CCS deployment in the 2030s, and the tens of gigaton scale CCS deployment in the 2100s. And one of the other trends that we're seeing in the Institute is around infrastructure and connecting infrastructure. So I think we've talked a lot here about individual clusters, especially in the UK. We have individual clusters in Teesside, in the Northwest. But more and more we're seeing that interconnectivity between clusters, and how we interconnect different regions that don't necessarily have access to nearby CO2 storage. How do we connect them, and how do we make use of the economies of scale with shared transport and storage infrastructure, connecting multiple emitters into common storage sites. And this then creates this shift in dynamics of CCS, because success of a CCS project is no longer about, does our capture system work, does our storage system work? It's much more about that value chain connectivity and the value chain coordination between different parts of that, the transport, capture, transport and storage. and how risk is allocated between them, how much of that risk is on the government, how much of that risk is taken on by projects, how much of that risk is taken on by the insurance industry. And that is one of the trends we're really seeing, and those robust risk sharing mechanisms are becoming more and more important in successful CCS deployment. Another trend we're seeing is on the financial side, and Ben touched on this in his presentation yesterday, but the Northern Endurance Partnership has been very successful in being funded by non-recourse debt, and that growing financial confidence in CCS is part of one of the trends that we're seeing. We also see equity investments, for example, global infrastructure partners investing in ENI's project and transport and storage project in the Northwest cluster. So that growing confidence in CCS as a bankable asset class is something that the finance industry wants to invest in, is interested in, and is very important and very crucial for this. But it's all underlined by the supportive policies, the policy frameworks, the standardized contracts, emerging insurance solutions, and that risk management approach that I was talking about on the last slide. We also see on the other side a lot of talk and chatter about the voluntary carbon market, and then increasingly about the compliance carbon market and how they can help grow CCS and how they can help generate revenue. Another thing that's not on the bullet points of this slide is also how funding for CCS can be developed through green premiums and selling low carbon products on the market to conscious consumers, as it were. And the EU's Industrial Accelerator Act, which mandates a certain amount of low carbon procurement for EU government entities, will be quite important in establishing that ecosystem. And together, these all help create revenue streams and long-term demand signals for CCS and help drive that financing side of things. So just to summarise, in terms of what's next for CCS, I think overall it's that CCS is moving from this ambition to real-world projects delivering, and I think we've seen a lot of that in presentations across today, but I think we're going to see more and more of that in the coming years. And so there's a strong project pipeline out to 2030s and beyond, and that 54% number of increase in operational projects from 2024 to 2025 just highlights that. But policy remains the primary enabler of a lot of those projects, and making sure the policy is in place and the supportive policy is in place is going to continue to be important in the future. And these policies and these frameworks do vary across different regions, and a lot of that's based on the starting point of those regions, but they are converging on that common goal of gigaton scale CO2 storage. And critically, this future scale depends on systems, not just individual projects working, but the systems that support them and the systems that connect them with other parts of the value chain and other sectors of the market, like insurance and finance, which don't know so much about the technical CCS community or technical CCS research now, helping them come on this journey with us and teaching them about how they can help support the industry will be increasingly important. So thank you very much. I think we're taking questions as part of the panel discussion, so I'll leave it there. Thank you.
Thanks, Hannah. That's on point and fantastic as well to have that highlighted about financial, the CCS being an investable thing. So yeah, great. I also wanted to highlight some of the commitment that our speakers make towards being here today. Hannah, you're avoiding writing your report. We had Sandra yesterday who was missing the Parliament voting on the 7th carbon budget, and we have Xi who's literally just flown in, landed this morning, got a train across, and I don't know what time zone you're on, but a different one. So come on up and we'll hear from yourself speaking about the Guangdong CCUS Centre.
Thank you.
You have that works.
Oh.
Please use the microphone, and I'll time you for 15 minutes.
Sure. So thanks for your invite. So it's my pleasure to be UKCCSRC's research center's meeting again. So my talk will briefly review China's CCS activity and the UK-China collaboration. Actually, in Chengdu, Destiny's was in Chengdu to have the natural meeting with Chinese government yesterday. I also presented CCS works there. So it has drawn a lot of interest from both UK and Chinese industry. So CCUS now become much more important since China allows the carbon neutrality policy in 2020, and carbon neutrality by 2060, and the peaking of carbon emission by 2030. So in the last few years, there are so many projects being proposed and developed in the country. And in the next 5 years, so from right now to 2030, China, like the UK, is facing very stringent carbon budget, and the policy for setting carbon budget just announced in April this year. So I think by the end of this 5 years, is going to be a lot of high concentration CO2 capture and storage projects. So roughly around 120 million hours, or 160 to 200 projects in China across the country. The total annual capture capacity now is well above 6 million tons here, and it's been located in most of the province. And I think Shanxi province in Mongolia holds a high proportion of CCS projects. So in China, I think UK and China has collaborated from 2005, and I think George was involved long before that, to look at how to build net zero coal-fired power plant, near zero coal-fired power plant. And right now, there are a few large utility companies demonstrating CCS at the megaton scale, including Hualong and the China Energy Corporation. So this China Energy project, hydro is 500,000 tons, and they are planning to do a 4 million ton project along with this project. And Hualong's project also started operations 1.5 million ton. So this is a Hualong Zhengling's project, and perhaps the largest post-combustion capture in coal-fired power plant right now in the world. There are, apart from conventional amine-based chemical solvent technology, there are many research teams in the country working on other lower technologies such as membrane, oxy-combustion, chemical looping, and other technology. And decarbonize cement, petrochemical, steel, and the coal chemical becomes an also important issue because it's really hard to abate. And China has built a lot of renewable projects. It's maybe a majority of renewables in the country. And this morning I heard the news of Chinese total power installed capacity is 4,000 gigawatts. When I worked with John on CCS in China, it was 600 gigawatts. So right now it's 4,000. So but industry decarbonization is very difficult to use green hydrogen. It's quite expensive and very difficult to modify the process. So in industry, a lot of companies are working on how to use CCS technology as a transition technology, including some pilot in cement sector and some 500,000 ton capture in Baotou steel in Mongolia and in the steel sector. On CO2 storage, there are a few oil companies working on onshore CO2 storage associated with enhanced oil recovery. In Guangdong, the CNOOC from 2021 started the first offshore CO2 storage project with a maximum capacity of 300 tons CO2 per annum. They use the CO2 naturally come from the oil field and capture the CO2. And there will also be some unconventional CO2 storage projects being investigated, apart from the cyanide formation projects mentioned here. Like Hualong is also doing already injecting 200,000 tons CO2 for cyanide formation storage from the 1.5 million ton carbon capture projects. CO2 storage and monitoring is a very big issue for the next step of collaboration. Even there are many projects, but in China, the CO2 regulation framework is still behind. And there's urgent need for the government policymaker to formulate how to monitor CO2 being stored, how to tackle leakage issue and how to manage long-term liability. So this has been raised on the policy agenda, and perhaps later this year or next year, you will see some announcement quite soon. Cluster development has also been considered by many provincial government and a large energy company, including British Netherlands company Shell has been very actively driving offshore CCS storage cluster in Liang Bay. Actually, Stuart was working on that area's geological analysis 15 years ago. And Shell is also working with Baowu to look at CO2 storage, capture, transport, and storage in Shanghai, Zhejiang's area. So there are a few large CCS clusters, but the challenge is the policy incentive is there, but still not strong enough to drive large-scale CCS projects to be in place, my colleague from GCCSI suggested. But in the next 5 years, if China doesn't follow the United States and insists on abating CO2 and towards carbon neutrality, it has to use CCS. We did stress testing for 8 largest Chinese banks last year, and they come out of many different technology, energy efficiency, switch to renewable green hydrogen, biomass, carbon capture and storage, all technology being assessed. And they come out of this. If you want to have a deep decarbonization, you have to use a large percentage of CCS. And those banks, some banks asking, are you fair? Because your institute's name is called CCUS Center, but actually we did a fair assessment. So there's not much alternative if you want deep carbon emission. So in the next few years, they are supported by UK Department of International Trade. We also investigated in different components of CCS how to drive some supply chain collaboration between British company and the Chinese company on capture, transport, storage, utilization. And in industry, there are some interest on financial interest on CCS technology, like CO2 utilization company, the first listed company of CCS been listed in Hong Kong last month, is a steel company investing in a new technology, converting CO2 into biological raw material. So there are huge carbon capture market and transport utilization in the country, and there have also been some works right now look at using captured CO2 for sustainable fuel, for synth fuel, for green methanol. But unfortunately, based on the EU's ICC standard, industry captured CO2 will only be acceptable until 2034. And the Chinese standard, they have different layers, and some layers may allow CO2 being captured from industry sources for sustainable fuel production. And there are also CO2 carbon storage related market, and we estimate if the carbon control policy becomes quite stringent, there will be a huge market from high concentration CO2, roughly 200 million tons in the country, will be able to capture in a low cost way. The cost is lower than $20 per ton, and will be carried off fairly soon. So since 20 years ago, there have been many UK-China collaboration projects, like NZ projects. We can celebrate 10, 20 years of NZ projects and many other projects. Many colleagues here have been participating in previous projects. With support from UK colleagues, including John, we built a carbon capture testing platform in Guangdong, have tested more than 10 different technologies, including John's 100% carbon capture idea. And we'll continue to use the platform, but also investigate a next generation of carbon capture testing, which is fully open to international community. So this is a supply chain report we look at. Recently, we also work on how to get the CCS study being published to the British government yesterday. in Chengdu, and it's quite important to understand how to deploy CCS when gas power plant or even coal-fired power plant in China in the future will work in a very low and fluctuating operational hour per year. So the cost can be doubled if we don't have a solution to get rid of the CO2 when this fossil fuel plant later become used for peak load, used for providing capacity. And in China, there have already been a very mature and comprehensive carbon management framework. There are very stringent mandate for each provincial and the municipal government leaders to maintain the carbon budget and be assessed every year. It affects their promotion, affect their punishment. And there are also central policy and a carbon market for industry enterprise. And at the project level, every new additional project with a million-ton emission, you have to prove you can get rid of a million-ton emission somewhere else, otherwise you are not allowed to rebuild. So at the project level, there's a project carbon assessment being started from 1st of September last year. And there are also carbon footprint related work associated with international dialogue. So, so we can see there are still many collaboration opportunities. I hope colleagues can look at this huge industry market, and including project and technology exchange, technology testing, supply chain integration. Actually, this photo was taken yesterday. I think we updated the slide in Chengdu. Yeah, in that next DG was there. And the CCS MRV CO2 storage and monitoring regulation is quite important, and I'm part of the policy drafting group. So if you have any suggestion how to deliver a comprehensive and useful CO2 regulation policy, that would be very interesting. We can't learn from EU CCS directive. It's too comprehensive, too complicated, it can slow down things. But if there's something in transition we can adopt, that will be very useful. And then offshore CCS always is a strength in the UK. And we can continue to work on collaboration in this field. Thank you very much.
Thanks so much. That's really great to hear that future look from the perspective of what's happening in China, also that export and partnership for that knowledge exchange, and also the visibility of CCS there at the kind of DESNES DG with that. I'm sorry, I'm being called by the GP. Mathieu, would you like to take? I might just take this call.
Yeah, go ahead. Okay, good morning. Yeah, so Mathieu Lucquiaud, I'm Professor of Carbon Capture and Storage at the University of Sheffield, also Deputy Director of the UKCCS Research Centre. I'm basically an engineer, and what I'm going to do here is I'm going to give you some of my thoughts about what's next for the UK, what challenges we're facing in terms of CCS deployment. What I'd like to do is go back to the basics. This is the global CO2 emission pathways from the IPCC for 1.5 degrees. We kind of started UK EU CCS deployment in the late 2020s. After we ignore the two Norwegian projects that we have, but we're basically starting a wave of CCS project which we didn't have before. And one important point is that the decisions that we make today, they're going to stay for this sort of legacy infrastructure that's going to be in operation for decades and potentially until the end of the century and beyond. So what I've got here is examples of other sort of public good legacy infrastructure that we currently use. So recycling centres, the sewage system, water treatment plants, natural gas pipelines. So this is the sort of thing that we're building now. We're building a public good legacy infrastructure for the waste disposal of CO2. Some of the immediate challenges that we're facing, so I think this is the point that Hannah made just now, is we're transitioning from individual project to effectively cluster, and there's sort of a need to build sort of a resilient CCS infrastructure. As we move to clusters, we're facing this kind of first of a kind challenges for clusters. So clusters are great, they reduce risk and cost for deployment, but they concentrate environmental impacts. So if you build several sort of aiming plants next to each other, you tend to concentrate the environmental impact from these aimings. So one of the challenges that we have currently with clusters is that we permit our aiming project on a project by project basis, and so we can have a project A using aiming A in a cluster, and that project A might be using all these sort of environmental limit for that aiming A in the atmosphere. If project B comes along and use aiming A, if project A uses all of the lamps, then project B has effectively a challenge there, and that results in effectively additional costs. So I think we have a way to potentially addressing those challenges, but this added cost that we have for the second or third movers that I think could be avoided if there was an element of strategic planning, and I think our regulatory regime at the moment doesn't facilitate that. So someone has to take ownership of that issue and potentially at own level, and make sure that we effectively end up in a situation where on a cluster basis we're able to have some strategic thinking in terms of how we put emphasis on minimizing the environmental impact from aiming deployment. We also have limited knowledge of what those aimings do once they reach the atmosphere, and how they react with sunlight or ozone. If we're going to follow a cluster approach, we might end up having cocktails of aiming in the atmosphere. So solvent A we might have very low level of solvent A in the atmosphere next to a very low level of solvent B. We don't really understand how solvent A and solvent B in the atmosphere might react under those sunlight conditions. Project developers don't, because they focus on the aiming that they will use. So we currently know that's again a strategic thinking in terms of the environmental emissions. Another challenge that we face is that CCS is a system of systems. Okay, I think we require sort of synchronicity of production, operation, and investment to roll out the chain, and we also need to think about new ways of operation. So in the UK, we're going to go for a model with gas CCS in the electricity grid, and we're going to have to understand the interplay between those gas CCS plants, the renewable grid, and the impact that has on the production of CO2. So we might be facing periods of periods of basically no production of CO2 when those plants are being dispatched. We might be facing periods where we have variable flow going into our transport and storage system. There's inbuilt flexibility in the in shipping, but in pipelines maybe less so. And effectively, at the end of the infrastructure, we have CO2 injection. So CO2 injection, I think, can tolerate sort of a flexible injection, cycling injection rate. So a cycling injection rate. But if we want to protect the long-term value of those CO2 storage assets, we must avoid cycling them all the time. So we currently have a transport and storage network code that's being developed in the UK, and I think we need to move to a system thinking approach in that transport and storage network code in the same way that we do the electricity system. So what I'm thinking here is maybe ways where we have some CO2 production capacity that support the continuous injection of CO2 into storage assets. So going back to my pathways from the IPCC, we're currently aiming for net zero by 2050. But just to remind ourselves that net zero by 2050 is an interim target, and that the long-term goal is to effectively net negative for decades. And effectively, if we plan for net zero by 2050, we might make life harder for ourselves when we try to go for net negative. So I think we should start planning for net negative today. And effectively, if you put that into the operation of CCS on the capture side, effectively we want to move to 100% capture all the time. So we kind of discussed that yesterday. We had Stavros Mikalos from Hull and John Gibbons showing us the modeling and pilot scale work, showing how we can effectively increase our capture rate to minimize residual emissions from CCS. Why do we want to do that? It's effectively we want to create space for harder to abate sectors, and also we want to actually displace the deployment of more expensive greenhouse gas removal technologies. The purpose of doing that is to effectively reduce total cost for the energy systems. So some of the work, I didn't put the figures here because they're not public domain, but some of the work that we've done with the energy systems catapult show that the value of going to 100% capture in the UK for all sort of CCS assets is I think it's 0.5% of total system cost. So it's a small number of a very, very large number, and that's about tens of billions of pounds per year in the 2050s. So if you want to capture all the CO2, what's the right capture rate? Where do you put the balance between sort of abatement fossil and CDR? So here, this is some a paper that we've submitted. It's looking at the levelized cost of electricity of a combined cycle gas turbine with an capture. On the horizontal axis, you have the capture rate, and this is the gross CO2 capture rate. So this is all the CO2 that passes through your capture plant, and effectively in a gas turbine, you're burning CO2 into air. So effectively, if you want to capture 100% of the fossil CO2 that's coming from natural gas, you need to capture 99.1% of the CO2 that's passing through your capture plant. The rest is atmospheric CO2 that is coming from combustion. So when you talk about 100% capture, really on CCGTs, we're talking about 99 and a bit. And effectively, what you have here, you have the levelized cost of electricity of the plant. So we've used US methodology from the DOE, capital cost for the US, but I've tried to make it UK relevant by using a capacity factor of 60% and effectively using natural gas prices for the UK. So you have the levelized cost of electricity here, which is kind of ballpark what we expect to see in the UK. You have 3 different lines, which shows how you can optimize your capture process by pushing harder your solvents on regeneration to reduce that levelized cost of electricity. And then the dotted line here is the marginal cost of CO2 avoided. So as you increase your capture rate, so each of these points, the plant has been optimized to minimize levelized cost of electricity. And you see as you get closer to so the 91.1%, the 100% fossil capture, the marginal cost starts to increase, okay? But it's kind of in the ballpark of the cost of direct air capture or basically BECCS. So effectively what this is saying is that you want to go all the way until you get to the, effectively your marginal cost gets to the cost of direct air capture or BECCS, okay? And that's potentially your right capture rate. But we can go, we can go pretty high effectively. So we can get our CCGTs to effectively zero residual CO2 emissions, and then we're looking at engineered greenhouse gas removal. In the UK, one of the challenges that we have, if you like, I guess maybe it's not a challenge, it's an opportunity, but we've put a ban on exporting waste. Okay, so we have to deal with our waste in the UK. We're rolling out CCS in the waste sector, so we are one of the first 2 plants in the world doing waste to energy CCS. So difference between WECCS and BECCS is that effectively WECCS you can view as an indigenous source of biomass. The biomass that's in your waste is if you like produced from UK waste, but it's biomass with strongly attached in the sense that you cannot separate the fossil carbon in the waste from the biomass carbon in the waste. And that leads to certain things. So if you here, what I've got here is a comparative life cycle assessment of 2 waste pathways that we are pursuing in the UK. So on the left you have WECCS, so that's waste to CO2 storage. And on the right-hand side, you have waste, municipal solid waste to SAF, sustainable aviation fuels. Okay, and effectively, if you compare the global warming potential, so that's the kilogram of CO2 equivalent per ton of waste. One is more negative than the other, so you get more climate benefit by effectively putting CO2 into the ground than you do by putting converting the CO2 in waste to a sustainable aviation fuel, because the fossil carbon in the sustainable aviation fuel returns to the atmosphere. Okay, and you don't get the, if you like, the negative emissions from the biogenic carbon either, returns to the atmosphere. So effectively, we have this question that we need to answer with waste. How do we maximize the climate value of this resource that we have? Do we go for biogenic CO2 in geological reservoirs, or and do we want to avoid putting carbon in SAF that will return to the atmosphere? If that carbon is fossil, that's not the right idea. So we need to do a bit of strategic thinking in terms of how the energy system, the waste system, interface and how they talk to each other. And I think we want to avoid having policies where effectively we're pushing waste to sustainable aviation fuels, because we could do better with our carbon, and that will potentially imply revisiting the waste hierarchy. Then I'm going to talk about DACs. So other ways we're doing engineered greenhouse gas removal in the UK. So we've got power BECCS, gives us energy security and greenhouse gas removals. DACS doesn't give us energy security. It's a cost. In the UK, we're a high fuel cost, high energy cost, high labor cost, high transport and storage cost environment. So if you take a given DAC technology, it's very likely that it will be cheaper to deploy it elsewhere. You might be able to, if you think about the Strathclyde project in the US, you sit right on top of your reservoir. You've got access to potentially low-cost renewable energy. So what we've seen in the Whitehead review is that we might, one of the suggestions here is that we might be thinking about international purchase of credits generated by DACs instead of potentially deploying DACs in the UK. And other countries are also thinking along these lines. So this is from Germany. So the German State Secretary for I think the Environment Ministry. Yeah, that's right. Talking about the adoption of direct air capture, it's likely to happen elsewhere than in Germany. So their model is to effectively potentially deploy German technology abroad and re-import the credits to Germany. So are we going to deploy DACs in the UK? Well, there's two pathways there. We could do the same as what's suggested by the Germans here, and then re-import credits, or we could look for a cost advantage. So unused transport and storage capacity, the use of waste heat. I mean, those ideas have been proposed. And then one other thing that potentially I think we ought to research in the UK is how we could use our point source conventional CCS infrastructure to reduce the cost of DACs. And effectively, this is a concept that we've been working on here at the University of Sheffield with Lucquiaud, where is he? There. John, Ryan Camden, and myself, looking at effectively an old concept where you sort of combine the air CO2 capture elements with a point source CCS technology. So there's various possible ways, but an example here with amine systems. So what you have here is a conventional in plant attached to a combined cycle gas turbine. So that's your gas turbine, heat recovery steam generator here. That's your amine plant, absorber, flue gas absorber, reboiler, sending the CO2 to compression here, and effectively you use the solvent in your flue gas absorber amine plant, and you send it to effectively a DAC absorber, where you capture CO2 from the air and you return the amine down to your process. The big advantage that you have here is that effectively the solvent that's captured has been loaded with CO2 from the air, and you send back to your flue gas absorber. You continue capturing CO2 from the flue gas, and you get to your reboiler with a high-rich loading. So yesterday we were able to show you that when you get a high-rich loading, the the energy, thermal energy that you put in your capture plant tends to be low. So effectively, we're able to do that with the same energy consumption as a conventional flue gas absorber system. And that leads to potentially cost reduction. So we've been working on sort of assessing that, and effectively, this is just to show what could be achieved. So this is again US data from the DOE. So we're looking at the green line is BECCS, so it's kind of half BECCS. It's sort of the co-firing of biomass with coal. So here there's no co-firing, and you're going all the way down to 50% co-firing of biomass. And in the UK, we think about going all the way down here. And here, this is your CCGT. You have the levelized cost of electricity. We've put a credit for CDR of $250 per ton of CO2, and effectively just shows that with a combined cycle gas turbine, and if you're capturing CO2 from your flue gas, so 100% of forceful capture plus CO2 from the air, you can get to a global warming intensity of your electricity generation into the minus 150 kilogram of CO2 per megawatt hour. So the UK grid has currently a carbon intensity of 150. Okay, so potentially from natural gas, you can decarbonize power and you can remove CO2 from the air. That's one of the advantages that we could have in the UK, having a point source infrastructure that could effectively facilitate the deployment of cost-effective DAC. So I'm going to end here. So I think some of the challenges that we face: cumulative emission CCUS clusters, the atmospheric chemistry of these amines, how we address the CO2 flow viability in our infrastructure. How do we get the best value out of our biomass that we have in the UK in our waste? We need to go all the way on visual emissions and capture all the CO2 that's coming from our commercial assets. And potentially, is there a future for that in the UK? Are we going to import credits from abroad, or can we find effectively a cost advantage in the UK with our newly existing infrastructure that would basically allow us to ramp up UK DACs? So yeah, thank you.
Thank you, Mathieu. Me standing there I wasn't being too ominous. I hope it was partly because I couldn't sit down discreetly. So thank you, Mathieu. If you want to just come to the front and join the panel, also G. I think, Mathieu, that's a fantastic slide to end on. I will skip on to the next bit about the panel discussion. But thinking about these challenges in this panel, we're going back to that question of what's the future. We're going to take questions from the floor. We've got actually, thanks to speedy speakers, we have got 20 minutes, just a bit under. But I think I'll get things started with an inclusive question that maybe you'll take, starting with yourself, Hannah. And that's just setting the scene. It's setting the scene and going, okay, well, given what you've just shared, what is the main key opportunity for CCS looking forward? And then perhaps what is that key barrier? So what's your kind of headline message of where the innovation or opportunity lies right now, and where's the number one barrier? So we'll take it in 10 minutes.
I think no? Sorry. Should be on that. Thank you. I think my key opportunity and key barrier are linked, and they're linked back to the policy that I kept going on about. That the key opportunity is in places where there is supportive policy, where you have things like carbon contracts for difference that make up the difference between the cost of emitting carbon, so the ETS price, and the cost of deploying carbon capture. So that's where we see the key opportunities. And then the key challenges are in places where we don't have that supportive policy for whatever reason, and how we overcome those challenges will vary depending on where we are in the world, but how do we create an environment where supportive policy can support projects where CCS makes most sense?
Okay, well, to me, I think we saw that a little bit in the presentation from Poseidon. Is the UK is blessed with CO2 storage. It's got the largest CO2 storage capacity in Europe. and it's got a huge opportunity to effectively monetize that and store CO2 from other countries. So I think this was only briefly mentioned, but if we can get that going, we'll have a sort of a very, very healthy CCS industry in the UK. And then the challenges, I think there are many, but the biggest one is effectively, we're doing this for the first time. We have these flagship projects. If we can build them roughly on time, roughly on budget, they will set a very strong example of what they can achieve. We talked about public acceptance yesterday. I think once we have those projects going to show to the public, then I think we must start seeing a shift in that conversation as well. So yeah.
Hi, thanks, Mathieu. I think there are many opportunities, like both the UK and China have very tight carbon budgets, like CB6, CB7, there's very steep reduction of carbon budget as well as in the EU and serving the EU. So there might be great opportunity to get some commercial projects down here as well as in China in the next 5 to 10 years. But we need policy support, like contract for difference, as you say. I think CFD has also been discussed in China, has also already introduced CFD to China for renewable in each province. Now may consider in CCS in the future. Secondly, negative emission technology demonstration would be very interesting, as Mathieu just said, including waste to energy, biomass to CCS, some waste heat utilization. I think this will bring up to agenda, and Paris Agreement Article 6.2 and 6.4, the bilateral multilateral ITMO transfer will soon be mature in the next couple of years. So they will also bring in some opportunity for country to achieve that NDC while implementing project in other very suitable locations around the world. So yeah.
That's really exciting, Scott. Any questions from the floor? Any of those? And we've actually got an amazing array of stakeholders in the audience. You might be coming with your own personal questions you want to ask the panel on the future, on CCS, or thinking about the themes we've heard in the session or the rest of them. Okay, so have I got a helper? No helper. Okay, thanks. That should be. Thanks, Diane. So the first question was. The first thing you are in the organisation department, that would be great as well.
My name is Sama Salim, and I'm an electrical engineer. At the moment, I'm not part of any organization. It's my personal interest that has brought me to this conference. So my question is, if we have two options, option one is we are capturing carbon from industry, and the country does not have any geological storage. So they have to transport it thousands of kilometers to another country. And the second option is if we have DAC on the near the storage location, so which option is better in terms of financial, environmental risk, and also these two factors.
I'd say that's a hard question. I think it's always very project specific and location specific. So it depends exactly, like Mathieu's point about if you're co-locating DAC with waste heat, then you can bring your DAC costs down. And if you're storing right there, then that can make DAC a bit more cost effective than reducing CO2 from industrial sites. I think the point that I would make is that we'll still have a need to reduce CO2 from industrial sites. We should do DAC as well. There's many sectors of the the economy that need DAC. So, for example, aviation, where you can't necessarily capture carbon off the back of a plane, but you're still going to need DAC to offset those emissions. And maybe the priority for DAC should be in offsetting those emissions from those sectors, whereas heavy industry should do the capture themselves, dependent on the project economics. I don't know if other panelists have discussion.
Yeah, I can add something here. The cost of DAC is in the sort of mitigation, in all the mitigation options that you have, right? DAC is the thing that you do last, right? So therefore, the cost of DAC caps the cost of, climate change mitigation, but also anything that's more expensive than DAC, that involves fossil fuels,
maybe you want to think about not abating those emissions and doing DAC instead. So if you're in a country, if you don't have CO2 storage, and if you have industry, you can transport some of your CO2 to Middle East or the UK for storage. But if you look at the cost of your policy, and we're seeing that already in Europe, we're doing policies where the abatement cost is higher than DAC, right? So you might want to think about, looking at those, engineered GGR options. Could be DAC or BECS. But if the cost of the alternative is higher than the cost of removing CO2 from the atmosphere, then you want to be removing CO2 from the atmosphere. You'd say something?
Yeah, in most cases, DAC is more expensive, unless you find a suitable storage site plus low cost of waste heat, like Iceland is an example. Yeah.
Hi, I'm Lisa. I'm from Innovate UK Business Connect. So my work primarily, I work with businesses to help them decarbonize using electrification, hydrogen, or CCUS. So I have two questions. A lot of businesses in UK are considered SMEs, 99%, and they are located at the dispersed sites, which is not captured as part of the CCUS clusters. I think they contributed around 50% of UK emission. So what sort of are they going to be covered as part of CCUS, or in terms of decarbonization, they are only going to be constrained by electrification or energy efficiency? That's my first question. Second question is, I think statistically UK industries are dying. So we are relying more and more on import. We see the closure of chemical plant in Scotland. So do you predict that it's going to have a domino impact to the CCUS project? Because it's like, if there's no demand, there's no need to have a project. So yeah, that's a question for me. Thank you.
Remind me, what's the second question again? Domino effect, yes. Okay. Well, I think you can I think turn the narrative around and say if you can deploy or demonstrate CCS in UK, and you can create these low carbon cluster, you might be able to reattract industry in the UK, industries that want to decarbonize. So I think it's also an opportunity to get new industries to come to the UK. I'm from France. One of the big attraction for France is its decarbonized electricity sector. A lot of investment, a lot of data center want to eventually come to France because with nuclear we have a very low sort of carbon intensity of electricity production. That's an example of how having a strong selling point in the decarbonization, if you like, race is a benefit to your country. So CCS can potentially reattract industries to the UK.
Yes, so I don't know whether your 50% means direct emission or including indirect emission, but this is my direct emission.
Yeah.
Okay, then a good way to do it is you have kind of like stress testing, and we have to give some guidance for industry to understand how to work out their abatement potential and cost. I presume Climate Change Committee, they have already done something for their carbon budget planning, and they have some nice diagram. I don't know whether this can down to individual firm, but it would be really useful. Individual firm have some tool used at a very low cost to understand their carbon abatement potential from various of technology. And in particular, they can guide them if they are building a new project with new emission, how this emission is going to be priced, and how the emission is going to potentially be retrofit or emitted or abated. So I think this will be very useful tool for SMEs. Yeah.
I think that answers the first question. So we have both questions answered, I think. So I think we have, question you there.
Yeah, thank you very much. Actually, my question is a little bit about the comparison between the storage, the capacities inside UK. I mean, the utilization, again, the capacities and the opportunities and outlooks in the UK. So given for example, if the clustering idea becomes like viable or becomes the thing that is backboned by policy or even supported by policy. So what do you think is the main bottleneck for not going through the path of the utilization and just like incentivizing the path towards the storage? I mean, what is the main bottleneck in the UK? For example, suppose we have like green industries like anaerobic digestion, it's like near 880 plants in the UK that are actively producing 50% of their product as carbon dioxide, which can be further, collected in the clusters and either been like stored on the ground in the UK because we have a good capacity for the storage. But my question is, if the clustering pathway becomes viable, what makes utilization more favorable over the storage? Is it still again the finance and the economic, or is it the policy, or is it something else?
Yeah, I think as a CCS institute, we tend to just look at CO2 storage, so we don't consider CO utilization. So this is more of a personal opinion, but CO2 utilization obviously has a greater revenue. You can see where your revenue can come from with CO2 utilization, especially if you make it into SAF, sustainable aviation fuel, and you sell it on the market. In the UK, we have the UK SAF mandate, which I think is 5% of UK aviation fuel needs to come from sustainable sources by 2030. So there will be demand from players to procure that SAF. So there will be demand for that, and that's easier to then justify the utilization options when you can sell it on the market. With storage, I think politically it's slightly more easier to justify in terms of those environmental concerns about why we're doing CCS in the first place. And if you have those CCS projects coming online that can help support decarbonisation of the UK as a whole, then I think that's very valuable for the wider community.
It's a good question, and we did some study from Liang province, a province with a very high per capita emission on planning of CCUS, including utilization. We visited every individual emission project, look at utilization potential, and finally the government become realistic and say, okay, we don't have so much utilization opportunity. I think that's only 1% of CO2 can properly be utilized around 2030, and we publish a report too, and they change their idea. So the realistic, we find out not many economic, financially viable CO2 utilization, and mostly at scale. If the source of emission is decentralized and the transportation nearby is not very good, but maybe utilization is a much better option. But when we talk about cluster, usually considering steel, cement, power, these large concentrated emission sources. And right now, there's still no single utilization solution can address the massive amount of megaton or multi-megaton level of CO2. And we talk about sustainable fuel could be potentially to use some CO2, because sustainable fuel, the green methanol, the premium price is more than $600, $800, and each ton of green methanol can only reduce 2 ton of emissions. So abatement cost is $300 per ton for get the green methanol, more than $500 per ton for SAF. So this high carbon price naturally will also drive utilization become viable, because these two sectors are very expensive to abate. Yeah.
Thank you very much. I think that's time, and I'll hand it to you to add something there.
I think just that often they happen in conjunction. So Mathieu talks about energy from waste plants. A lot of energy from waste plants are thinking about utilization for their biogenic component of the CO2 stream. Very roughly, it's 50-50, 50% biogenic, 50% fossil coming out of an energy from waste plant. So sending 50% of their CO2 to utilization and 50% to storage is also one way of covering the cost of storage through the revenue you generate from utilization.
No, thank you. I think it's useful to bear in mind that the CCS projects are happening all around the world, sometimes in hub type situations and other times not. And I think for me, if I may add, this future look for CCS. It's about the diversification of the types, styles, formulations, business models, whatever, you know, that we're going to be seeing coming forward, because every different area, different countries have got a different flavour of doing things, a different need as well, that kind of place, kind of back to place and requirement. So thank you very much to our panellists, to our speakers in the final session.